Bismillah Rahman Rahim. In this session, we will discuss exam style questions on the topic of pressure from O-level physics subject. And here we have some true and false statements. And number one is pressure is the force acting on unit area. So it's true because the pressure is defined as a force per unit area. So this force is acting on a unit area. So this is true. The force is calculated from force per area. True. And the SI unit of pressure is the Pascal, which equals 1 Newton per square meter. This is also true. The greater the area over which a force acts, the greater the pressure. This is false. If the force applied in a small area, then pressure will be greater. So this is false. So force is equal to pressure into area. True, because pressure is equal to force upon area. So force is equal to pressure into area. So this is true. The SI unit of pressure is Pascal, which equals 1 Newton per meter. No, it's 1 Newton per square meter. So this is false. Now question number 2, calculate the pressure exerted on a wood block floor by each of the following. Number 1, a box weighing 2000 kilonewton is standing on an area of 2 meters square. So if this box is 2000 kilonewton in an area of 2 meters square, then the pressure is equal to force per unit area. Here we have 2000 kilonewton and divide by 2 meters square. So this is 1000 kilonewton per meter square. In a second case, an elephant weighing 200 kilonewton is standing on an area of 0.2 meters square. So the weight is 200 kilonewton, area is 0.2 meters square. So force upon area is equal to 200 kilonewton divided by 0.2 meters square, and we will have 1000 kilonewton per meter square. So this is again the same pressure. In the third case, a girl of weight 0.5 kilonewton wearing high-heeled shoes standing on an area of 0.0002 meters square. So we'll divide this force by this area. So this force or weight. So this force is weight basically. So pressure is equal to force per unit area. This is 0.5 kilonewton divided by 0.0002 meters square. And by dividing this, we have 2500 kilonewton per meter square. So we can see that the highest pressure is 2500 kilonewtons meter square. So this is the highest pressure is from the third one. The case of a girl with a very small weight as compared to the previous two, but exerting higher pressure, that is 2500 kilonewtons because of a small area. A wood block floor can withstand a pressure of 2000 kilopascal or 2000 kilonewtons per meter square, which state which of the object in A will damage the floor and explain why. So the previous two cases, 1000 kilonewton meter square is same and less than 2000 kilopascal or 2000 kilonewtons per meter square. So the third case where the pressure is higher than 2000 kilopascal, so the only high-heeled shoe will damage the floor because it exerting the highest pressure, that is 2500 kilonewtons per meter square or 2500 kilopascal. Question number 3, in a hydraulic pressure, a force of 20 Newton is applied to a piston of area 0.20 meter square. The area of the other piston is 2 meter square. The pressure applied by the smaller piston to the liquid is transferred through the liquid and applied to the larger piston. So we have to calculate the pressure transmitted through the liquid. So we have to find the pressure. So hydraulic pressure, the force of the applied piston is 20 newtons and the area of that piston is 0.20 meter square. The area of the required piston, other piston, is 2 meter square, and we have to find the force on that side. So the pressure, we have to find the pressure first. The transmitting pressure is force by unit area. This force and this area is, because this force is applying on this area 0.20 meter square, so we'll divide this force by this area, and we have 100 Newton meter square. And in a part B, calculate the force on the larger piston. Larger piston is basically 2 meter square area. So force is equal to pressure into area, and this pressure is obtained as a force per unit area. So we have this 20 Newton and divide by 0.2 meter square multiplied by this larger piston area is 2 meter square. So by simplification we have obtained 200 newtons force. So the larger piston is feeling or observing 200 Newton force by applying a 20 Newton force on a smaller area piston. So in the question number 4, the pressure in a liquid varies with depth and density. State whether the following statements are true or false. Number 1, the pressure in a liquid increases with depth. True, because as the depth increases, the pressure increases. The pressure in a liquid increases with density. Yes, if density increases, then pressure increases. The pressure in a liquid is greater vertically than horizontally. No, it's not true, because liquid exerts equal pressure in all directions, and this is called a Pascal law. So this is not true. It exerts equal pressure in all directions. Calculate B. The increase in pressure at a depth of 1 meter below the surface of seawater of density 1150 kilograms per meter cube. So we have to find this delta P, change in delta pressure at the depth of 100 meters. So from the surface we are going 100 meter below the sea level, and this is rho is 1150 kilograms meter cube, and this G is gravitational field strength 9.8 newtons per kilogram, and this is the depth below the sea level is 100 meters. So on multiplying we have obtained 1127 kilonewtons per meter square, or 1127 kilopascal. Question number 5, state the equation which relates the change in pressure in a liquid to the depth below the liquid surface. So an expression of the change in pressure delta P at a depth of delta H below the surface of a liquid of density rho can be found by considering a horizontal area. This is this area on which liquid is exerting pressure on this direction. The force acting vertically downward on A equals the weight of the liquid column of height delta H, and the cross-sectional area above it. Then the volume of liquid column is this delta H, and this cross-sectional area, this is the volume in this container, or and this volume is multiplied by the density of this liquid. So the mass is obtained. Mass is equal to density into volume, and volume is delta H. A is volume and this rho is the density. So mass is obtained as rho delta HA, and weight of the liquid column is mg. So m is mass, so in place of mass we can write rho delta HA, and this g is gravitational field strength, and the force on the area A is this weight of the column. So this is rho g delta H Ag, as the pressure due to the liquid column is equal to force per unit area, and we will divide this weight or force by the unit area. By this area, this A will cancel this A, and we will get this pressure due to liquid column. We can write delta P is equal to rho g delta H. Delta P is the change in the pressure beneath the surface of the liquid at depth delta H due to the weight of a liquid of density rho, and g is the gravitational field strength. This can also be written in a word as this rho is basically the density, g is gravitational field strength, and this delta H is the change in height or change in depth. So this pressure acts equally in all direction at depth delta H and depends only on delta H and rho, and its value will be in Pascal if delta H is in meters and rho is in kilograms meter cube, and G is in newtons per meter, newtons per kilogram, and gravitational field strength is given in newtons per kilogram. So this is all the derivations we have learned, or this is the idea. Some liquids level, and as the liquid level increases, the pressure at the bottom will increase. In a part B, identify the unit of pressure, that is unit force per unit area. Unit of force is Newton. Well, the unit of area is meter square, so Newton per meter square is called Pascal. Calculate the depth of water of density 1030 kilogram meter cube, where the pressure is 7.5 into 10 to the power 6 Pascal. So we can write delta H is equal to rho is given as 1030 kilograms meter cube, P is 7.5 into 10 to the power 6 Pascal. So delta H is equal to P upon delta rho g, and this delta P is given as 7.5 into 10 to the power 6 Pascal. So 1030 is the rho density in place of this, and in place of g we can write 9.8 newtons per kilogram. On simplification we have obtained 743 meters. So at the depth of this 743 meter, the pressure will be 7.5 into 10 to the power 6 Pascal. In a figure 6, here we have a barometer, simple barometer. What is the region A? The region A is the space above the mercury in the tube is a vacuum except a little mercury vapors. So some mercury vapors and vacuum is there in this 2 centimeter height. What keeps the mercury in the tube? The weight of the column of mercury is balanced by the force due to atmospheric pressure pushing on the mercury in the ball. So the pressure is exerting here and it's pushing it up inside the capillary or tube, or so this external atmospheric pressure is pushing this mercury upward in this column. So this is the weight of the column. The mercury is balanced by the force due to atmospheric pressure pushing down the mercury in the ball. So this is simple. What is the value of the atmospheric pressure being shown by the barometer? So barometer is, the pressure is exerting here. So this pressure difference, that is 74 centimeter, is the pressure. The atmospheric pressure shown by the barometer is 74 centimeter of mercury. Now, the question number D, state what would happen to this reading if the barometer were taken up a high mountain. Give a reason. In a high mountain region, the atmospheric pressure becomes low. So, in that case, this mercury level will decrease. So, in a high mountain region, the reading of the barometer will decrease because of low atmospheric pressure. So, that's all from this chapter on pressure. The next time we will learn some other topics.